Greetings, I am now going to present to you the models and processes we will use all along this module. As it was introduced in the previous video, the objective of this course is to give you models and methods in order to create a sizing process of a mechatronic system using a technical specification document which contains first, functions and operational modes. They are generally the reason of a component choice. Then, performances and limits. They are generally the reason of design objectives and constraints. The objective here is to choose the optimal components. Once chosen, the components can either be manufactured by ourselves or bought from a supplier. In order to size a system, from a system integrator point of view, it is necessary to use different types of models. First, simulation models that will help us compute the different sizing parameters which are necessary to choose the right components. Then, estimation models that will help us obtain the main characteristics of the components using only a restrained set of key parameters. Finally, evaluation models, which will ensure that the components will respect the lifetime required in the specifications. This diagram shows the information flow between these different models. We will take interest in each of them successively during different classes of the module. First, the establishment of sizing scenarios and mission profiles. Then, the choices and implementation of the adapted simulation models, but also estimation models using scaling laws, evaluation models for the computation of lifetime, and operational limits of the simplified expressions of simulation models, which are meta models, and finally, the establishment of sizing processes and the optimization of it. The typical methodology to follow in order to create a mechatronic system can be summed up within the following steps. First, you have to analyze the architecture of the system and determine the sizing scenarios. You will find a car game on Moodle to help you achieve this task. Then, you have to determine the active design drivers using analytical calculation, direct or inverse simulation, and scaling laws. After that, you will establish a sizing procedure and clearly define the optimization problem using scaling laws once again, but n-squared and influence diagrams as well. You will also define and create meta models using RSM models. When all of the previous steps are completed, you will finally explore different design solutions and try to optimize them thanks to Excel Solver. To conclude, you will have to validate your solution thanks to analytical calculations and over simulations.